Hello again, guys. We're here in 12.5 talking about isosceles and equilateral triangles. We're going to start off today's lesson by looking at isosceles triangles. So you'll see over here you have a graphic of your isosceles triangles. We're going to start by talking about some of the terminology because these triangles are really useful. You see them all over in the real world, and now that you know to pay attention, I bet you will not be able to not see them. So the congruent sides of the isosceles triangles are its legs. Hopefully you remember that an isosceles triangle means that it has two sides that are congruent. Euclid would say exactly two sides, but kind of our new definition is at least two sides. And then the third side is called the base, and that side is not necessarily congruent to the other two. If this third side is congruent to my other two legs, then it turns into an equilateral triangle. Because these two sides are congruent to each other, we also know that these two base angles are congruent to each other. So here we see our first theorem dealing with isosceles triangles. We call it our isosceles triangle theorem. It states that if my two sides are congruent to each other, so if AC is congruent to BC, then angle A must be congruent to angle B. Now, a common misconception here is why that happens. Angle B actually relates to the opposite side. So B relates to side AC because the angle of B is determined by how long AC is, and likewise angle A relates to side BC because this angle is determined by how wide it needs to be to span that gap. In case my little explanation is not good enough, let's go ahead and prove our Theorem 20. So we start with a triangle XYZ, and we say that XY is congruent to XZ. That is our given information. We then drop a line here from X down to the middle of YZ, which makes this line our angle bisector. So now angle 1 will be equal to angle 2 by the definition of angle bisectors. And by the reflexive property, we know XB is going to be equal to itself. So now we can prove these two different triangles, because we've created two triangles now. We can prove them congruent by our side angle side postulate. And since we know that those triangles are congruent, we can say that angle Y will be congruent to angle Z. That is because of our corresponding parts of congruent triangles are congruent, and now we will actually get into abbreviating that. If you would like, you can start writing that as CPCTC. Congruent or corresponding parts of congruent triangles are congruent. And likewise, we have the converse of the isosceles triangle theorem here, stating that if my two angles are congruent, then the sides that they are opposite to also must be congruent. Remember, the side between those two angles we don't know anything about. Please make sure that you work through part 1 of the lesson and then come back here once you have your answer for the got it. So go ahead, pause the video, make sure you work through the lesson, come back for the answer. So our first question here is asking, is WVS, the angle WVS, so that angle right there, congruent to angle S? And if I look here, I've got two congruent side symbols, my little tick marks here. So that then tells me that the opposite sides of them are congruent, so our angles also must be congruent. If we look here at B, asking can we conclude that RUV is isosceles. So here's my triangle RUV. Now we might be able to prove a couple things, but we only have one angle given to us inside of here. We don't know anything about angle U, and we don't know anything about angle V in the triangle, so we do not have enough information. And there is the answer written out with all of the details needed. So try this practice problem here. It's in your notes, it's not in Pearson. We start out looking for what VT is congruent to. So I've gone ahead and highlighted VT, and I've actually highlighted the angle that it relates to. So go ahead and try to figure out if VT is congruent to something. Fill in the rest of these steps if you can, and then come back for the answers. So to answer that question on what VT is congruent to, if I look at this angle relating to the entirety of VT, I can also look at this angle down here relating to all of Vx. So my answer there actually becomes Vx by the converse of the isosceles triangle theorem, because if I know the angles are congruent, then I know the sides are congruent. So then I move on to UT is congruent to what, which is also congruent to Yx. So we don't even really need the Yx here really, because if I come over here and look at my graph, or look at my picture, UT relates to this angle right here. So if I look at another angle congruent to that, I've got this angle at T, so that angle here then relates to this side, UW, so that becomes my answer. If we look at number 3, we're looking for what side is congruent to VU. So when looking at VU, I see that VU is part of the larger segment involving UT as well. And since I know that UT is equal to YX, a good place to think would be our VY right here, because I have this base angle down here relating to the entirety of VT, this base angle down here relating to the entirety of Vx, and if I just use the segment addition postulate, I can prove, I'm kind of blocking stuff, I can prove that they are congruent. So when I'm looking at angle VYU, that's this angle over here that I've highlighted in purple, so it relates to the opposite side of VU, and since I just proved that VU was congruent to VY, my VY side right here relates to my angle here, VUY. So you could either call it VUY or YUV. We kind of already saw this in our proof of Theorem 20, but here Theorem 22 states that if a line bisects the vertex angle of an isosceles triangle, remember the vertex angle is the angle between my two congruent sides, then that line is also a perpendicular bisector of the base. Now remember that when I drop this angle bisector, I actually then create by side angle side two congruent triangles, and since my triangles are congruent, that means my segment AD must be congruent to my segment BD, and because I dropped it straight down and my base, it meets my base at 90 degrees, that means that it is a perpendicular bisector. So make sure you've worked through the second part of the lesson before trying this got it. Pause the video, try to get your answer, and then come back to see my answer. The first thing given is that measure of angle A is 27 degrees. So pause the video now if you've not done so. Because of my isosceles triangle theorem, I know that my two angles at the base would be congruent, so angle C must also be 27. So now that we've notated that both of these are 27 degrees, we can then set up our triangle sum property, because the three angles of a triangle will always sum to 180. Now pay attention that this question mark right here relates to the entire of angle B, so be careful as we solve this. So we would combine our like terms, get 54 plus our unknown angle equal to 180. I use my algebra to solve, and I find out that my unknown angle equals 126, but that's the combined angle, so we need to bisect that to find out our angle x, since it only wants angle CBD, and we get 63 degrees. All right, pause the video and try this practice. There are two values over here you're solving for, as well as two values here, so pay attention to that. All right, if we look at problem 5 first, I'm going to approach solving y to begin with. So because this is an isosceles triangle, one thing I know is that this angle right here must also be y. It's got to be congruent because of my two congruent sides right here. So I start my equation by saying that y plus 100 have to equal 180. From there, I just use the algebra to combine like terms. Then I subtract 100 from both sides, getting that 2y is 80. I then divide on both sides and see that y must be 40. On solving for x, I set up the same thing, except I know that my two base angles here must be 50. So then I combine like terms, and I get 80. You can obviously see the answers over here for 6, but I will be right back to walk through the step-by-step. All right, so I start looking at this triangle by identifying its isosceles, and by the converse, I know that these angles must both be y. So now my 110 and my angle y here create a supplementary pair. And because they're supplementary, I know that they'll add up to 180. So I set up my equation like that. I then use algebra to solve and subtract 110 from both sides and get that my angle y is 70 degrees. Now, of course, with all of these, I don't need the degrees symbol because it is here in the variable term. When I look at solving for x, what I know is these two base angles are both y, and my top angle is x. Therefore, I can substitute in that I now know y is 70. I can combine those like terms and say that 140 plus x equals 180, and then I can just find out that x is equal to 40. So now we have a corollary to Theorem 20. So first we want to talk about what a corollary is. So a corollary is a theorem that can be proved easily using another theorem. And because a corollary then is a theorem, we can use it as a reason in our proof. So our corollary to Theorem 20 relates now instead of just having two sides congruent, we now have all three sides congruent. So if the triangle is equilateral, notice lateral is relating to the lengths of the sides, then the triangle must be equiangular. And we all know, hopefully, that equi prefix means the same. Please make sure you've worked through the third part of the lesson because this relates to problem 3. What we're told here is if ADE, so this angle right in here, angle DEC, this angle right down here, and angle ECB, this angle right there, all are the vertex angles and all have measures of 58 degrees. What are the measures of angle A and then angle BCD? So go ahead and try to figure that out on your own, come back for the answer. All right, let's start by solving our angle A, since that is our easier angle to solve. We know that this vertex angle up here is 58 degrees, so I can set up my triangle angle sum property by making this equation here, knowing that these two base angles here have to be congruent. So I use a variable to represent that. I like x. So then I combine my like terms. I want to subtract 58 from both sides. So I get that 2x is equal to 122. I would then divide on both sides and get that x is 61. Now when I look at BCD, BCD is this obtuse angle here combining one vertex angle and one base angle. So what we have to do to set that up is take one vertex angle and one base angle measure, add those together, and we get that it is 119 degrees. I'm going to use these last few minutes of the video to run through the practice or the remaining practice problems on your notes. So go ahead, pause the video and try to make it through all of those practice problems that you're able to. So I look at ABC, my angle here is being this obtuse angle. So what I see is it is comprised of two smaller angles. This angle is part of the equiangular triangle here, and since it's equiangular, I know that it takes the 180 degrees and divides it by 3. So we know that that angle angle DBC, this angle in here, must be 60 degrees. So then I need to solve this angle ABD, and that is part of an isosceles triangle, so I know that this other base angle is 66 degrees. So I just say that 66 plus x is 180. And from there I combine like terms, solve for my x, and now to find the real measure of ABC, I need to add these two together, and we get our answer to be 108 degrees. If you have not done so, pause the video and try number 8. In 8A, because I see that I have an isosceles triangle with congruent sides, I know that the angles opposite them will be congruent, so angle A here is 70. Over here, I'm just showing that my angles are congruent, and I'm given the measure of one of them, which means my other angle will have the same measure, so B, angle A, is 53. Go ahead, try number 9 if you've not done so yet. So in A, we're given one angle, and we see that we have an isosceles triangle. So since this is my vertex angle, I know my two base angles will be congruent, so they will both have a value of x. So I can just say that I have 2x's plus 30 equal to 180. I subtracted the 30 from both sides and got 150. I combined my x's, got 2x, and then I solved to see x is 75. It's worth pointing out over here that this 42 degrees is relating to this angle L. So when we're trying to solve for x, pay attention that this is a bisector of my angle, which also means something important about what these angles down here at O will end up being. And there is the work for 9B. Here's your answers to both of them. I'm going to quickly run through the rest of the answers from your notes. If you have any questions from them, please let me know on Schoology, send me a message, or talk to me in class. So what I see here is with an isosceles triangle, and I'm given one base angle, I know there's always two congruent base angles. So one of my other angles will be 23, and then when I add those up, I get that the remaining to get me to 180 degrees is 134. That's all I have for today's lesson on isosceles and equilateral triangles. Please make sure you've worked through the entire lesson and try your homework, and let me know if you have any questions, comments, or concerns. Have a wonderful day.